Okay, students, we are on Unit 8, Day 2. We are actually getting into the TRIG. We are going to talk about TRIG ratios. We're going to talk about what SOHCAHTOA is, and then we are actually going to find missing side links using TRIG. And so if you have not done this in ACT Prep, you'll be seeing it for the first time. If you have done this in ACT Prep, you might find that it's really easy. You are definitely going to need your calculator. Your calculator has to have sine, cosine, and tangent. You are not going to be able to answer my questions if you don't have these keys and on your calculator. You do have these on your phone. You have to turn your phone like this, and then those keys will show up on your phone as well. Okay, so here we go. What is trigonometry? Trigonometry is the study of measurements in right triangles. Write that down. So we cannot, well, we can. There's some theorems that we can use when we don't have right triangles. But what we're doing right now is we are focusing on right triangle trig. Okay. Each acute angle in a right triangle has the following trig ratio. Now, what I want you to remember is that a ratio is just a fraction. Okay. So when we get down here and it says find the trig ratio, you need to remember that your answer is just a fraction in simplest form. Okay. So we've got to keep that straight because students think this is the hardest part of it. It's actually the easiest part of it. Okay. So we're going to learn what trig is, what the trig ratios are in a right triangle. All right, so you see these strange words right here. This is sine, cosine, and tangent. There are actually three other trig ratios that we have. They're inverse functions. We're not going to talk about those. But we are going to talk about the three basic trig functions. Before we do that, we've got to learn how to label our picture. If you can't label the picture, you are never going to get the trig correct. Sorry, let me click this one more time. Okay, so when we are talking about trig, what we have to do is we have to have what's called a reference angle. The reference angle is going to be one of the acute angles. There's different ways that they will ask you to find trig, and they'll designate which angle. Sometimes they will do this. The reference angle is A for this problem. Okay. Sometimes they will do this. My reference angle, there's not a letter there, but my reference angle is where the measurement is. And then in the next set of notes, you're going to find out that sometimes they'll put the X inside here. Okay. So we have to have a reference angle. So to start off for this one, I'm just going to put a little mark here and color this in to show you this is the angle that I am talking about. Okay, so we need to label our sides with the words that you see here. We've got opposite, hypotenuse, and adjacent. And those words are all mixed up in these ratios that we're going to use. So from my angle, this is how you tell what's what. From the angle, you can draw a line to the side that's opposite. Okay, you will be next to the side that is adjacent. You're like, well, Miss Ernsberger, what about this side over here? Well, we're going to have the hypotenuse, and you should automatically know which one is the hypotenuse. Okay, so from my reference angle, and the reference angles will switch in the problem, you've got your side that is opposite. You've got your side that's adjacent, which is touching that side. And then you have your hypotenuse, okay, which is the side that's always across from the right angle. So you have to be able to know which side is which in order to use the trig ratios that we have. Okay, so in my picture, the sine is going to be the ratio. Ratio is what? A fraction. So it is the fraction of the two numbers in this picture that will be the opposite over the hypotenuse. These are going to be represented by numbers. And so whatever number is here, I would put it over that, and that's going to be what the sine is equal to. Okay, cosine is going to be the adjacent side over the hypotenuse. And then tangent is going to be the opposite side over the adjacent. Okay, so these are the three rules that you have to memorize, and there's an easy way to memorize them. Okay, typically I don't fill out this section right here, so put an X, because I like to go ahead and do it and teach you how to do that with numbers rather than they want me to do it with the letters here, and we're just going to skip that. Okay, so how do I remember these three rules that we have? Well, we use what's called SOHCAHTOA. Write this down. All right, SOHCAHTOA. There's all sorts of things on YouTube that you can find. If you type in SOHCAHTOA, you have videos that you can watch if you feel like you need extra help. But what these letters represent: sine, cosine, tangent, and then notice it's O, H, and A all mixed up. So the O stands for opposite, H stands for hypotenuse. Let's go ahead and write that down, and I'm going to start abbreviating. So the sine, that what this tells us is that the sine rule means put the opposite number over the hypotenuse number. The cosine rule means put the adjacent, not to be confused with adjective, okay, adjacent over the number that's representing the hypotenuse. And then the tangent rule says put the opposite over the adjacent. Okay, and that's what SOHCAHTOA means. So if you memorize how to spell this, you have your rules right here every single time. SOHCAHTOA, and I write this on my paper every time I do trig. Okay, so let's look at question number 1. I'm going to use pink for this side of the problem. Okay, so I'm using pink over here, and then I'm going to switch it to another color when we get over here. So A is my reference angle. I'm going to do this. Okay, A is my reference angle. And so before I do anything, I have to label my sides. So this side over here, without me messing up the picture, this side over here is my opposite. And all you have to do is put the O. This side over here is across from the 90-degree angle. That's my H. So then the one people have trouble with is the adjacent, and that's the side over here. I do that every single time. I find my opposite first, then I put where the hypotenuse is, then lastly, I know the last one has to be the adjacent. So remember, these answers here, they're just fractions, but we need to make sure we simplify them. Okay, so sine is opposite over hypotenuse. Opposite over hypotenuse, that's just 5 over 13. It's that easy. Okay. Cosine is adjacent over hypotenuse. It's going to be 12 over 13. And then tangent is opposite over adjacent. So that's going to be 5 over 12. None of those reduce, so you're done. If they reduce, and they will, then you have to reduce. Okay, now I'm going to grab green, maybe. Okay, so I'm going to do this part in green, and I want to show you how it changes. So this time C is my reference angle. So I've got my reference angle here. So the hypotenuse is never going to change, but for angle C, this is my opposite. So I'm looking at the darker color. Grab a highlighter if you need to distinguish what we're doing. So that's my opposite because it's across from it, and that means this would be my adjacent. Okay, so follow me. Sine is opposite over hypotenuse. So look at the green. That's 12 over 13. Cosine is adjacent over hypotenuse. That's 12 cosine. Oh, I'm looking. I lost what color I was looking at. Cosine is adjacent over hypotenuse. That's 5 over 13. And tangent is, look at the green, opposite over adjacent, 12 over 5. You leave it improper. Do not mix, do not write it as a mixed number because we need to see their ratio, which is a number to another number. Okay, now we are going to make an observation. So I've got my highlighter to show you some things that are going on. If I knew how to get these answers right here, I don't have to do this is a little shortcut. I don't have to do any work to get these answers here, and I'm going to show you why. Do you notice that answer is now the first answer? Do you notice that answer is now the answer here? What happened to the third one? Well, the third one, I'm going to write it in pen. The third one is just a flip, okay, from here to here. So if you memorize sine, cosine, tangent, and you get these first answers, all you have to remember, if there's a problem where you have the blanks over here, this answer is going to go here, this answer is going to go here, this one you flip every single time. We'll try to do that down here. Okay, question number 2. We're missing a side. I get so frustrated when I ask a student, how do we find that side? Well, we have to do what we did yesterday, which is why we learned yesterday. We have to do the Pythagorean theorem. So 9 squared plus 12 squared equals c squared. I'm going to let you guys trust me that we get 15 for this answer. Okay, and we're going to put that in the picture. Number 1 question on your assignment. Find the missing side so that you can find these measurements. Okay? All right, so I'm going to write SOHCAHTOA. I can't see my notes above. All right, so this is what I write on my paper when I'm doing trig. All right, so we're going to do this part in pink. That's my reference angle. All right, so let's label our pieces. This is my opposite because I can draw a line across from it. This is my hypotenuse. So that means this has to be my adjacent. Okay, so sine is opposite over hypotenuse. Sine is opposite over hypotenuse. This tells you what you're doing. So opposite over hypotenuse is 12 over 15. Does that reduce? Yes. 3 goes into 12 4 times. 3 goes into 15 5 times. You can put that in your calculator and you can hit the ABC key and hit enter and it will reduce it for you. Yes, you have to reduce. Okay, cosine is adjacent over hypotenuse. Well, that's going to be 9 over 15. That also reduces to 3 over 5. Yes, you have to reduce. Tangent is opposite over adjacent. Tangent is opposite over adjacent. That's 12 over 15. And yes, that is going to reduce to 4 over 3. Do not leave your answers unreduced. Okay, now to get the other answers, I could go back in and I could use my green pen and I could label this my O and I could label this my A from here. But I don't have to because I know this little shortcut here. I know this answer is going to be 3 over 5. So sine is opposite over hypotenuse. 9 over 15 reduces to 3 over 5. Cosine is going to be 4 over 5. How'd you get that, Miss Ernsberger? I used my shortcut. Okay. And then what do we do here? You flip. So this is going to be 3 over 4. Just to check, tangent of x, tangent is opposite over adjacent. How do I know that? It's right here. So in green, tangent is opposite over adjacent, 9 over 12. I wrote that down wrong. That should be a 9. I just noticed that. Sorry about that. Y'all be coming to me asking me for Miss Ernsberger. Man, hate it when that happens. 4 over 3. Yeah, that makes perfectly good sense. 12 over 9. So this would be 9 over 12, which is 3 over 4. So sorry about that. Okay. Number 3. All right. Go ahead and use the Pythagorean theorem. To find this missing side. Okay. Pause the video. Do that for me. All right, so you should have got 30. Okay, now we're going to find all of these answers. Okay, so to get you started, I'm using green for all this. Okay, and our reference angle is L. Reference angle is L. So 30 is my opposite. My hypotenuse is 34. That means 16 must be my adjacent. Okay, go ahead and do problem number 3 by yourself. All 6 blanks need to be filled in. Okay, here's all the answers. So first of all, I recommend writing this down when you're doing your work so you can see what you're doing. Sine is opposite over hypotenuse, so I put 30 over 34. Cosine is adjacent over hypotenuse, 16 over 34. Tangent is opposite over adjacent, 30 over 16. And then I reduced, and then I did my little shortcut. I know this answer goes up here. This answer goes down here. And this answer is flipped, that shortcut. If I wasn't going to do the shortcut, my reference angle would be M. Okay, and this would be opposite, this would be adjacent, and you could get the answers that way. All right. Now, like I said, students tend to think this is the hardest part of the work, but it's not hard because you're learning what SOHCAHTOA is. All you have to remember is a ratio is a fraction. It has all 3 numbers. Because what's going to happen for the rest of the work is we are not going to have all 3 numbers, and we're going to be finding missing values. Okay, when we're finding missing values, we get to pick up our calculator and actually use those keys that are on the calculator. Okay, so at the top of our paper, since we're on the back, let's write really big, SOHCAHTOA. Okay, guess what? The more you write it, the more you're going to learn it. Okay, and we are rounding to the nearest tenth for our problems. Okay, so we are going to have a process here. First thing we're going to do is we are going to label. Label our O, our A, and our H. Okay, then the next thing we're going to do is we are going to set up. So we're going to set up our problem. And then the third thing we're going to do will be using our calculator. Okay. All right, so let me show you how we do this. All right, here's my reference angle. Wherever the degree is, that's your reference angle. I usually do this. And we're going to label only the pieces we have because if there's nothing here, I don't need to use it. I can't use something that's not there. So this is my opposite, and this is my hypotenuse. Now, this is how easy this is. I only have O and H. I'm not using the adjacent at all. Look up here. Out of these 3, when I say 3, we know which 3 I'm talking about. Which one of those 3 has an O and an H? There's only one answer. Okay, this tells you which one of these we're using because there's only one of them that has an O with an H. So I'm going to write down that word. So it is sign. Don't say sin, sign, sign, sign. Say it, sign. Okay, now this is what we need to learn when we're doing these problems. When we are using our calculators, an angle always follows the trig word. Okay, so an angle for my problem is going to be the 28. Now, when there's a number here, that's when we're allowed to use our calculator. So sine of 28, sine and write the angle in its opposite, which is my x, and hypotenuse, which is 19. All right, we are going to have two types of problems. Either it's going to be a multiply problem or it's going to be a divide problem. All right, before we jump into using our calculators, we need to make sure all of our calculators are in the same mode. Do you see right here where it says DEG? That means we are in the degree mode, which is what we need. If your calculator has been accidentally hit with buttons and it says other stuff right here, then you need to flip your calculator over and hit that reset button, or you need to do clear memory reset down here and reset it. Okay, it's just as easy to hit that button right there. If you have a graphing calculator, okay, we need to hit mode, and you need to see how mine's on radians because I just changed my batteries. I need to have it on degree. So what I'm doing is I'm arrowing down and I'm arrowing over and I'm hitting enter, and it puts the dark black box on degree, and then I can hit second quit and it takes me out of it. If I went back to mode, now you can see the degree is lit up. You have to do that. If you have a Casio calculator, good luck with that. Throw your Casio away and get a Texas Instruments. Okay? All right. So, two types of problems. You're going to ask yourself, how do I get x by itself? Well, this is x divided by something. The way we undo divided by is we multiply. Multiplication undoes division. So to get x by itself, I have to multiply by 19, and I'm going to put that over here in the front. Okay, because we will never change this number here. This is the degree. So this has to stay. So I'm taking 19 and multiplying it times the whole thing. So what happens is this is gone, and I have x equal to, and I am going to put this in my calculator. Now, let me show you how easy that is. Okay, so I'm going to put 19. You don't have to put the dot. If you want to put times, you can, but your calculator knows that we're multiplying. I'm going to hit sign, and it's actually going to bring that word up. It opens a parentheses for me to put the degree in, which is 28. And if you're OCD, close your parentheses, but you don't have to. All right, so this is telling me 19 times sine of 28. I could also put sine 28, close the parentheses, times 19. Okay, as long as I don't put the 19 inside here, we're good. And we're going to get 8.9. That means this side right, whoops. There we go. This side over here would be 8.9. Okay. Let's do another one. Okay, so number 5, here's my reference angle. What would be the name of this side right here? Opposite. Hopefully you got that right. This is the hypotenuse, which there's nothing here. We're not going to write anything down, so that means this is the adjacent. So then I ask myself, what uses O and A? Look up here. Nope. Nope. There's only one thing that uses O and A, so I'm writing down tangent. So I'm going to put tangent. The angle always follows the trig, and then tangent is opposite over adjacent. So x over 32. All right, we are going to multiply by 32 to get the 32 off the bottom. I'm going to squeeze it in the front right here. 32 tangent 41, and this is what we're putting in our calculator because this cancels out and it leaves us the x. All right, so go ahead and put this in your calculator and write down the answer. All right, this is what I got. I put 32 tangent 41 and I got 27.8. 27.8. All right, number 6. So same thing. This is my reference angle. This is my hypotenuse. It's across from the right angle. So this is my opposite, which we do not need. This is my adjacent. I look up here and I ask myself, what uses the A and the H? Cosine. So I'm writing COS, cosine, cosine 21. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. All right, you should be able to finish that problem on your own. Go ahead, use your calculator, finish that problem. Here's how I put it in my calculator, 26 cosine 21, and that gives me 24.3. Round correctly. You'll lose points if you're not rounding correctly at this point. It is not okay for you to not know how to round 24.3. Okay. So those are the basic, that's one of each, showing you sine, cosine, and tangent, showing you how we labeled the problem and how when the x was on top, we simply multiplied. All right, would you do number 11, no help from me? Number 11, get your final answer. Okay, let's see what you did. So this is my reference angle. This is my adjacent. This is my hypotenuse. What uses an A and an H is cosine. Super easy to figure out what we're doing. This is going to multiply by 11 to make these cancel out. Multiply by 11. This is what I put in my calculator. 11 cosine 64, and we get 4.8. Okay, now we're going to switch gears, and these 4 problems here, or at least these 3, are going to be division problems. So it's going to look a little different. Please pay attention. Okay, so let's go ahead. We're going to set it up the same way. All right, here's my reference angle. This is my opposite. This is my hypotenuse. Okay, so what uses O and H? Sine is the only one that has an O with an H. So we're going to write sine, angle follows the trig, and we're going to put O over H. So this time, what's different between this one and these others is my X is on the bottom. It's going to be a little bit of a process, okay? So I'm going to show you how to do it, and then I'm going to teach you the shortcut. Okay, show you how to do it, teach you the shortcut. What we're going to do is we're going to put this over 1, and we are going to cross multiply. Okay, so cross multiply. X times sine 33 equals 1 times 15, which is just 15. And then to get X by itself, y'all, trig is just a number. Sine of 33 is just a number, so I can actually divide by it on both sides. And what happens is this cancels out with this. And now my X is all by itself. Guess what we're putting in our calculator? Okay, so we would take my calculator and I would go 15, hit the divided by key, and we're going to put sine, and I'm going to put 33. That's what it looks like. It's not multiplication this time, it's division. 27.5. Okay, that is the longer way to do it, and I'm going to teach you something. Okay, so let's write it down. if you're going to hear me say this, if X is on the bottom, move the trig to the bottom. Okay. So back at this problem, I had sine 33 equals 15 over x. That was the problem. If x is on the bottom, move the trig to the bottom. All I have to write down is this is 15 over the trig moves to, nope, 33. Sorry, can't have two x's in the problem. Sorry about that. There we go. So all I do is I put this on the bottom. The way we did that right here was I showed you that we just put this over 1 and we cross multiplied and it gave me the same thing right here. This is a shortcut that I like to use. If x is on the bottom, move the trig to the bottom. If x is on top, you just multiply. If x is on top, it's a multiplication problem. If x is on bottom, it becomes a division problem. This is what I want you to do. I want you to learn it this way. Okay? All right, number 9. Do this one together. Here's my reference angle. So that means this is my hypotenuse. This is my adjacent because this would be opposite. All right, what uses A and H? Cosine. So we're going to write cosine 43 equals adjacent over hypotenuse. Cosine, put the degree, adjacent over hypotenuse. If x is on the bottom, move the trig to the bottom. If x is on the bottom, move the trig to the bottom. If x is on the bottom, move the trig to the bottom. This is what you're putting in your calculator. Could you please type that in your calculator? I'm going to give you a point for getting that right. That's what it looks like. And we get 49.2. Okay, so now you should have had enough practice to be able to do number 10 completely by yourself. Go ahead and do number 10, please. I got 8.1. Okay, so this is my opposite. This is the hypotenuse. Hypotenuse is across from the right angle. This is my opposite. This is my adjacent. It's touching the angle. What uses O and A is tangent. So tangent 72 equals opposite over adjacent. And so if x is on the bottom, move the trig to the bottom. I put it in my calculator and I get 8.1. Okay, so I have a question for you. We didn't do number 7. Would you do number 7 and think, is it a multiplication or is it a division problem? Go ahead and do number 7. Number 7 was a multiplication problem. So this is my reference angle. This is my opposite. This is my adjacent. So what uses O and A is tangent. O and A. Hopefully you figured out which trig function we're using. So tangent 55 equals x over 8. And then to solve that, I multiply both sides by 8. So multiply by 8 over here. That cancels out. Multiply by 8. This is what I put in my calculator. 8 tangent 55. And I got 11.4. Okay, we're almost done. So when you have word problems, the word problems will be exactly like the ones that we did above. You just have to draw a picture. So number 12 says Jake leaned, we're leaning, y'all, people lean ladders all the time in right triangle trig. So Jake leaned a 12-foot ladder against a house. If the angle formed, now watch this, by the ladder and the ground. Where is the ladder touching the ground? A little bit of common sense right here. So here's my ground. Here's my house. how far from the base is on the bottom, did he place the ladder? So this is my X right here. Okay. So then I'm going to show you we're doing the same thing that we did above. Here's my angle. This is the opposite. If you want to put an O there, you can, but we're not using it. This is my hypotenuse. This is my adjacent. What uses A and H? Guys, if you don't pick the right one, you're not going to get it correct because they would all give you different answers. So cosine 68 equals adjacent over hypotenuse. Is this a multiplication or a division problem? It's a multiply problem, multiplication. And if you put that in the calculator, you get x equals 4.5. And that would actually be feet because it's a word problem. Okay? All right, I'll help you draw a picture. Y'all have to get to where you can draw pictures on your own, but we're talking about a ramp is used to load suitcases on an airplane. So if I'm talking about a ramp, it's going to look like this. And the suitcases are going up the ramp into the airplane. All right, it says a ramp is used to load suitcases on an airplane if the cargo door is 7 feet. So that means here's my airplane and here's the cargo door. Okay, so you can visualize that. And it's 7 feet off the ground. And the angle formed by the end of the ramp and the ground, again, touching the ground. So this is 25 degrees. It's not a very big ramp. How long is the ramp? Okay, when we're talking about long, we got to talk about some things. This is the vertical height. This is the horizontal distance. How long something is, if we're long, the ramp, this is the ramp. So if I want to know how long that is, that's my X. Okay. All right. Go ahead and finish that problem. This will be the last question that I ask you. All right, check your answer. This ends up being a division problem. Here's my O. This is my H. Opposite hypotenuse. Sine uses O and H. So sine of 25 is opposite over hypotenuse. Looks like this. This is a division problem because if X is on the bottom, move the trig to the bottom. And if you don't remember that, then go back up here where I actually did the cross multiplying and look at what I did. Okay, so this is what I put in my calculator, and I got 16.6 feet. All right, we're done. I know those were a little long for notes, but when we learn something for the first time, it does take a little bit of instruction to teach you the things you need to know. Go ahead and mark this video as done to get it off your to-do list, and you are done with your first day of TRIG. Thanks.